Okay, going to continue on the algebraic combinations of functions. We have this for my f of x, this for my g of x, and now we want f plus g. We'll do the work over here. F plus g, f is x squared minus 2x minus 15 plus g, x minus 5. Keeping the exponent 2 of x by itself, I have 1x squared laying around. I have a minus 2x plus an x becomes a minus 1x. And I have a minus 15 and minus 5 becomes minus 20. F minus g, come over here, x squared minus 2x minus 15 minus, and this is where you put that sign in there to keep yourself from messing up on that minus a minus 5. That becomes a, when I take away the parentheses, that becomes a minus x plus 5. Now, still, I only have 1x squared laying around, so it's still 1x squared. I minus 2x and minus another x, that becomes a minus 3x. I am subtracting 15, adding 5, so that becomes a minus 10. F times g, that's the hardest part. Let's do that. X squared minus 2x minus 15 times x minus 5. Let's do the x times all of this, and then do the subtract of 5 times all of this. X times all of this is x cubed minus 2x squared minus 15x. Now subtract 5 times all of this. So it's a minus 5x squared. And a minus 5 times minus 2x gives you a plus 10x. Minus 5 times minus 15 gives you a plus 75. 5 times 10 plus 5 times 5, 25, 50 plus 25. So that becomes a plus 75. So combining the, well, there's only one x cubed, so x cubed. Combining the x squareds, I have a minus 2x squared and minus 5x squared. That becomes a minus 7x squared. Minus 15x plus a 10x, that becomes a minus 5x. And all that's left over in the constants is plus 75. F over g, well, let's do the factoring and see if we can help it. X minus 2 times x minus 15. I think I can see a factor there of x minus 5 times x plus 3. And I divide out x minus 5 when I do f over g of x. I get x plus 3 left over. X minus 5 divided by x, or times x plus 3 divided by x minus 5. Those two cancel out. And I speculate, but I want to be careful, x not equal to 5. But we're happy with that answer. We divide out the x minus 5s. The last one of the combos, this is the hardest part, so we're giving you the most practice here. F plus g, x squared minus x minus 30 plus x minus 6. Have 1x squared minus x plus x. Oh, the x's cancel out. minus 30, minus 6, minus 36. And just for fun, I recognize that as both are squares, so that can be factored as x minus 6 times x plus 6, but we don't need to. F minus g of x, well, I'll just change the plus to an x, the plus to a minus over there. It's still only one x squared hanging around. Minus an x, minus another x, that becomes a minus 2x. And I have to remember it's minus x minus 6 in parentheses, so I better remember that it becomes a minus x plus a 6 outside of the parentheses when I'm subtracting. So, minus x minus another x, minus 2x, minus 30 plus a 6, minus 24. And of course, the most difficult one, we'll multiply it out, f times g, x squared minus x minus 30, times x minus 6, x times everything, x cubed minus x squared minus 30x, minus 6 times everything, minus 6x squared, minus times a negative 1, that becomes a plus 6x, minus 6 times a negative 30, that becomes a plus 180. Now, find all our x cubes. There's only one x cubed hanging around. There's a minus x squared, and a minus another 6x squared, so minus 7x squared. Minus 3x plus 6x becomes a plus 3x. And the 180. Plus 180. F over g, let's see. X minus 5, x minus 6 times x plus 5. I see the factoring. They've made it easier for me. X plus 5 is the f over g. X plus 5. There we go. A little practice there for you. Of the hardest ones. Now let's do a little bit of evaluation really quick. We have that table up there. We'll come back to it. We're looking for f of g of 0. Well, first thing we solve, let's solve for the middle part. We want the middle part becomes f of, well, g of 0 is 3. So f of 3. F of 3 is 8. Remember, that's f. This is f. This is g. This is x. So f of 3 is 8. F, or g of f of 2. Well, that becomes g of, well, let's see, what's f of 2? F of 2 is 6. So that becomes g of 6 becomes 7. F of 5. A little tricky there. There's f of f. So that becomes f of, well, what's f of 5? F of 5 is 1. F of 1 is 2. G of 9 becomes g of, well, g of 9 is 1. And g of 1 is 8. Combination. Well, we take what I like to show, take this and I like to convert it to my favorite form. F of g of x. That's what that is. So put g of x wherever I see x in f. So g of x will go right here. All right, and this is what g of x is. So I take 3 times feed it g of x. 3x squared plus 5x. And then add 4 to it. And now just multiply it out. That becomes 9x squared plus 15x plus 4. That's my answer. Inverse, remember what we do. We put this in the form y equals 13x plus 11. Solve for x, and then switch the x and the y to get inverse of x. So, solve for x. Well, subtract 11 from both sides. Now, divide both sides by 13, and x is by itself. Now, any function that I feed here and get an answer, it will give me back x. So, I just switch x and y to get inverse, and just basically I'm just saying, what you feed me I'm going to call x instead of y. So, equals x minus 11 over 13. Last one. Same technique. Y equals 1 over x plus 15. Solve for x. Multiply by this. Divide by that. Common thing. I get x plus 15 equals 1 over y. And now subtract 15 to get x by itself. So if I take any number, put it underneath 1, divide 1 over that number, subtract 15, and I get this number, well, if I call that number x and that number y, I now can get my inverse. 1 over x minus 15. Meaning, my function, if I take any number, put 1 over it, get the inverse of that number, and subtract 15. When I do that when I have figured out that number by doing this, I'll get my number back. So that's what we call the inverse. 1, take any number, 1 divided by that number, and subtract 15. If the number happened to be calculated by like this, well, 1 over that will become x plus 15. Subtracting 15 from that gets me back that number. So therefore, if I feed this into this, I'll get my x back. Thus, inverse. And that concludes a little practice with function combination.